Well, welcome to the other side of medicine. I'm Dr. Krystosik, aka Dr. Good Carbs. Glad that you joined us this evening, and we are looking for a great program tonight. You know, this is the other side of medicine, the gathering place of common sense, science, and nature. We bring together things that you're not going to hear on the typical radio stations. You're not going to hear in your doctor's office because your doctor doesn't know about the things we're talking about tonight, especially, which is the microbiome, the bacteria that live in and on our bodies. And we have a special guest with us tonight that I'm pleased to tell you about. It's Bill Shaddle. He's a former senior director of medical education at Metagenics, which is one of the premier nutritional supplement companies in the country. As a matter of fact, internationally. And he was the founder of a functional medicine consulting firm as well. And he's been helping doctors understand and apply nutrition as a therapeutic tool for over 45 years. The man's got some experience. So
Hi,
Bill
Dr. Krystosik.
I'm sorry, Bill's been the guest speaker for groups of doctors, pharmacists, and allied health professionals throughout the United States, Canada, Europe, Mexico, South Africa, and Australia. You have been around the world, literally.
Yes, I have. I've traveled over 2 million miles on the American Airlines alone, so I'm glad to be off the road for a while. Good to see you, Dr. Krystosik. How you doing?
I'm doing great, wonderful, and terrific. Why don't you ask me why?
Why?
Well, it's funny you asked me that. Well, the first reason is we live in a great country.
We do that.
And second, I believe we serve a wonderful God. And then I feel terrific because I'm talking to you.
Well, isn't that kind of you? Thank you. And I feel terrific because I get to talk with you too and your guests. Nice to see you.
Wonderful. Let's get the show on the road here. People are interested in the microbiome, the bacteria that, as we talked about, living in and on our body. So, Bill, tell me, first of all, you know, there's some really confusing terms that are floating around. There's, microbiome, microbiota. Could you kind of help to clarify for us what those terms mean?
Yeah, I'd be happy to. First of all, microbiome. Microbiome is an umbrella term, and biome refers to the aggregate DNA of all of the different bacteria that live in us and on us. Micro meaning referring to the bacteria themselves. So microbiome is the aggregate of all of these bacteria. It's kind of, as I said, the umbrella term. Microbiota refers to the bacteria themselves. So when people talk about the microbiome, they're generally referring to all of the bacteria as an aggregate, and specifically the DNA that make up those bacteria. And the microbiota would be the individual species of those bacteria that make up the microbiome.
Mm-hmm. Okay. So tell us a little bit about some of the factors that affect the microbiome, the microbiota. What are the things, some of the biggest factors? Give us three of them.
Okay, well, that's a really good question. They are affected by the same things that affect us. They're symbiotes, which means that they depend upon the environment that they live in. And since they live in us, the things that affect us are going to affect them. So they're very much dependent upon the pH in our gut. And by the way, they don't just live in the gut. You mentioned very accurately that they live in us and on us. So they live everywhere. They live on our skin. They live in our mouth. They live in our lungs. They live in our digestive tract. They live in the vaginal tract of women. So they are quite literally everywhere. And they vary by the environment that they find themselves in. They've even found that on one part of the tooth in the mouth, a different strain of bacteria could live on a different part of the tooth, on the same tooth. And they vary according to the pH where they're found, according to the temperature, according to the food that's available to them. And I'll get to that. I'll circle back to that in a minute. And they vary according to the stresses that they find in their environment. So in that sense, they're very much like we are. we're a product of the stresses that we find ourselves exposed to as well. And the types of stresses that they find themselves exposed to are the other bacteria that they're in contact with. So think of a healthy forest, and that's probably the best metaphor for thinking about the bacteria that live in our digestive tract. And we tend to focus on the digestive tract because that's the probably the most productive area of research for scientists, and the one that has probably the most profound impact on our health currently. The skin is also a barrier for the bacteria that live on our skin, and protects us and protects our internal environment from the bacteria that live on our skin that could make us sick, and in some cases could even kill us. But in terms of what's going on inside our digestive tract, we depend on those bacteria and they depend upon us. So over the millennia that we've been on this planet, we have adapted to those bacteria. So we depend very much on them for certain things that help to keep us healthy. For example, they produce vitamins that we don't produce, like B12, for instance, and they produce hormones, and they produce neurotransmitters, and they produce other chemicals that we depend upon to help to maintain our health. And then we produce substances that are beneficial to them.
So how many bacteria do we have in our body?
Oh, that's a really good question. We have literally many, many more bacteria that live in us and on us than we have cells in our body. There's a very interesting book on that topic called 10% Human, written by a scientist who got the title from the observation that there are roughly, at least at the time the book is written, the observation was that there may be 10 times more bacteria than there are cells living in us and on us than there are cells in our body.
Oh,
And
who's running the show?
Yeah, exactly. Well, exactly. And while that number may not be as accurate as it was thought to be when the book was written, there are certainly 10 times more DNA in those bacteria as an aggregate than there is in our body. So her contention was that when we talk about us, we talk about us as discrete individuals, we probably should be including those bacteria as part of this aggregate. And rather than thinking of us as being separate individuals, we should include these bacteria as part of us, in which case then we're part of a much larger organism, kind of a macroorganism, which includes these bacteria.
So there are, I know that we have like up to over 100 trillion.
Right.
That's a hard number to wrap our heads around. 100 trillion bacteria in and on us.
Right.
That's it's almost hard to believe. And there's 10 times, or they're thinking 10 times more of the bacteria than our human cells. That's pretty amazing.
Right, it is. And when you consider that each of those bacterial cells produce substances which have an impact on us, we ignore them at our peril. So we're just beginning, and I say we, the scientists who are studying this are just beginning to understand the impact that these bacteria have on us. In fact, there was a study a couple of years ago that looked at the impact of statin drugs, and the statin drugs, as you know, are used to control cholesterol and have an impact on cardiovascular risk factors. And they said that because statin drugs are metabolized by bacteria in the gut, maybe what they're really looking at is not the impact of the statin drugs on cholesterol, but the impact of the statin drugs as metabolized by the bacteria in the gut. And maybe what we're really seeing is a different measure than cholesterol metabolism, but more of an impact by the bacteria on the statin drugs having an overall impact on cholesterol.
That's interesting. I've never heard that one before. That's
isn't it? Isn't it?
Yeah, it really is.
So they were saying that maybe we need to go back and relook at all of those studies from the perspective of what's really going on, rather than just the single variable of statin drugs on cholesterol, but statin drugs in combination with the bacteria that are there, because those bacteria change from person to person. it's not the same bacteria within all of us. In fact, the bacteria that's in your GI tract is going to be different than the bacteria that's in my GI tract. And even the bacteria that's in your GI tract is going to be slightly different than the bacteria that's in the GI tract of the people that live with you in your household.
Yeah. So when you look at those numbers of the bacteria that are living in our gut, what percentage is living in the gut? If we have 100 trillion cells that are bacteria, what percentage approximately would be inside the gut of those cells?
I'm not sure I understand your question. Ask me that a little bit differently.
How many trillions of cells do we have inside of the gut of bacteria?
Oh, well, I think the number continues to be about 10 to 1. About 1/10 of the cells that we're looking at in the gut are going to be human cells, and the other 90% are going to be the bacteria
Right.
that
Well,
live there.
what I'm asking, Bill, is like how many gut bacteria are there? So there's 100 trillion estimated that we have of bacteria in and on our bodies. Do we have
Oh, I see your question.
25 trillion? Do we have 50
Yeah,
trillion?
the vast majority of the 100 trillion cells that we say are bacterial cells live in the gut.
Okay.
So
Got it.
by far the vast majority, trillions
Okay.
and trillions of cells.
Okay, got it. Okay, so what are some of the factors that affect those cells? Because obviously there's good ones and then
Yeah.
there's bad ones, and we want to get into that a little bit. But let's talk
Yeah.
about the good ones right now. What are three factors that affect those bacterial cells in a positive and a negative way?
Well, the main things that affect them are your diet, our diet, the foods that we eat, because they eat the things that we eat. And interestingly enough, most of what the good bacteria consume are the things that we can't consume. They're the undigestible fibers. So when we eat carrot or celery, the fiber that's non-digestible to us is their lunch. That's their fiber. That's their food and what they consume. And then they convert that into a type of energy for themselves. They're able to take that carbohydrate, which is a non-digestible carbohydrate for humans, and convert it into an energy source for them. And then in return, they produce what are called a different type of a carbohydrate, which we can then consume, a short-chain fatty acid, which we can then consume and which benefits the cells that line our digestive tract. So it's very much a symbiotic relationship. So the first thing that's beneficial or that has an impact on them is the food that we eat. The second thing that has a potential impact.
Before you leave that, I just want to mention the big word was carbohydrate, which many people have a fear of carbohydrates, and that's the very thing that the healthy bacteria thrive on.
Right.
I tell people there's such a carbophobia today that you could drive up to a bank and you could have a piece of bread and hold up a bank with a piece of bread. That's how much fear there is.
Yeah. Well, don't forget that these carbohydrates that these bacteria consume are carbohydrates that do not provide energy to humans. They're non-digestible to humans. So these would be the type of fiber that just provides bulking agents. So think in terms of things like oatmeal that does not provide an energy source. They're non-caloric to humans. They're non-digestible. So they're like part of a salad. They don't provide an energy source to us, and they're beneficial to the bacteria. The second thing that is potentially an impact on the bacteria are if we eat or if we consume certain types of pharmaceuticals. For example, if you take a course of antibiotics, antibiotic, the term biotic is the same thing in microbiotic. They kill the bacteria. The antibiotic doesn't know the difference between a good biotic or a good bacteria and a bad bacteria. So it kills both indiscriminately. So they, in addition to the microbe that it's trying to get rid of that may be making you sick, they're going to kill the friendly bacteria as well. And one of the challenges that's associated, that's been recognized for a long time, associated with taking an antibiotic is that it does kill the friendly bacteria. And after a course of antibiotics, you can get what's called an antibiotic-associated diarrhea, which is directly caused by that die-off of the friendly bacteria in your gut, which then can linger on. In fact, that's the topic of that book I mentioned before, 10% Human. That researcher went to South America and picked up a number of bacteria there that and then the antibiotics that she took to get rid of those bacteria stayed on and made her sick for years after the fact. So medications that people take can have an impact on the bacteria that live in their GI tract.
You know, Bill, there's research that shows that even one course of antibiotic in your lifetime, just one course, can disrupt the bacteria that's living in your gut for your entire lifetime if it's not properly reestablished.
Yeah, that's true. And then lastly, a bad diet. In one study, it showed that that for example, a high fat, what they called a Western style diet for as little as 3 weeks contributed to a change in the microbiome in the GI tract that was associated with a significant disruption in the microbiota in the negative sense. In other words, it contributed to a die-off of the friendly bacteria and an overgrowth of the unfriendly bacteria, which then led to what is called dysbiosis. And dysbiosis is a disruption of the friendly versus unfriendly bacteria. Mm-hmm. So those would probably be the three main things that can cause or that have an impact on the bacteria population in the GI tract.
Yeah. Well, you brought up an interesting point about the saturated fat disrupting the healthy bacteria. I'm sure you are familiar with the research done at the Cleveland Clinic with TMAO and how it increases the risk for atherosclerosis, the clogging of the arteries. When people eat too much saturated fat, then what happens is that bacteria works on that fat and turns it into plaque inside them and causes heart disease and heart attacks and strokes.
Yep.
So that's the danger point. And so many people today are eating, as you mentioned, they're eating less carbohydrates and more saturated fat. They're disrupting the balance, aren't they?
Yeah, they are. And you add that, and that has a compounding effect to the other variables that contribute to it. So the source of these bacteria for most of us, it actually comes from two different primary sources. We get it, these bacteria, we originally get it from our mothers, either during the birth process or at the mother's breast. And then it's reinforced in our life through cultured dairy products or through live bacteria in our food. So, for example, yogurt, kefir, buttermilk, sauerkraut, foods that are cultured or that have a type of bacteria in them as a part of their natural fermenting process. Well, how many of us eat those foods anymore? And when we do eat them, how many of them you're one of the few probably, but here's the problem that has emerged. The type of yogurt that was originally identified 75 years ago as being associated with improved health is not the type of yogurt that most people find in the grocery stores these days. That type of yogurt was found to be too tart for the average palate. And so it was replaced with a different type of yogurt that was sweeter. Well, that type of newer yogurt, which was more favorable for the palate of today's modern society, had a different type of bacteria in it that wasn't as beneficial to humans. It was a type of bacteria that didn't have the health benefits that were associated with longevity that was originally found in the Caucasus Mountains in Eastern Europe, where it was originally identified or was originally found to be beneficial. So what we've done is, ironically, replace the health benefits with a different type of a cultured dairy product that had fewer benefits. Secondly, instead of feeding babies at the breast, in many cases, people have been sold on the concept that you bottle feed babies. Fortunately, we're kind of getting away from that. We're getting back toward a more natural approach to breastfeeding and normal vaginal delivery of birth rather than C-section. But it was during the birth process of going through the birth canal and then putting the baby to the breast is where the child was first introduced to the healthy microbiome.
Yeah. So what people need to understand is, as the baby comes through the birth canal, you're basically getting baptized with healthy bacteria if they
That's right.
have a normal birth, a vaginal
That's right.
birth. But
That's
when
right.
they don't, what happens?
They get introduced to a very different type of bacteria. The bacteria that they're introduced to, if it's a C-section or if it's bottle fed rather than breastfed, matches the type of bacteria that's on the skin of the doctors and the nurses that are in the operating room, rather
Yeah.
than, or even the mother, rather than the bacteria that's in the birth canal. And that's a completely different type of bacteria. And unfortunately, the bacteria that's associated with the normal vaginal delivery and breast milk is associated with a much lower incidence of things like childhood obesity, allergies, upper respiratory infections, and even type 2 diabetes as the child gets older, than is the bacteria that's associated with C-section and with bottle-fed infants. And there's pretty good evidence to support that. So, uh, the old midwives knew what they were doing.
So give us some more information, Bill, if you will, about what are some of the, you mentioned vitamins that the bacteria make that we don't make, like B12 and some other vitamins that they make. What are some of the other beneficial effects of the healthy bacteria living inside of our gut?
It's a good question. As we learn more about these bacteria, we find, and this is a kind of an interesting upside down a way of approaching it, but we find that the absence of the friendly bacteria is what we're learning is that the absence of these friendly bacteria is associated with virtually every type of dysfunction that you can think of. So it's yet to be established that the friendly bacteria cause, how do I put this? They haven't identified that this particular bacteria contributes to health yet, if that makes sense. In other words, they haven't said this bacteria is what prevents diabetes. What they have found is that the absence of these bacteria or the presence of unfriendly bacteria is associated with type 2 diabetes or obesity or Alzheimer's disease or anxiety or depression or cardiovascular disease. In fact, if you a disruption in the friendly bacteria in the GI tract has been demonstrated to be associated with just about every single chronic disease that you can name. Now,
Bill, it's really interesting you just said that because, as you know, Hippocrates, the father of modern medicine, said all disease begins in the gut.
yeah,
And now science is beginning to prove, and to a large extent, what he said.
yes, yeah, that's absolutely true. And I phrased it the way that I did. It sounds kind of counterintuitive, and it might sound kind of weaselly to say it that way, because it's tempting to say that we know that these friendly bacteria prevent all of these diseases, but that hasn't been demonstrated in the science yet. So I have to be very careful to say it the way the science supports, which is that the absence of the friendly bacteria, or more specifically, a disruption in the balance of the friendly versus unfriendly bacteria, is clearly associated with the presence of these chronic diseases,
Bill,
cardiovascular disease, arthritis, and so forth.
now that you bring that up, I want to have you to talk a little bit about obesity, because it segues just perfectly into that, because the bacteria that's been linked to people who have obesity, as you know, is called acromencia. And it just perfectly fits what you're just talking about right there, because they found that with acromencia, hey, Bill, could you have something in the background that's really coming out loud?
Um, I can't hear it on my end. I apologize. Maybe let me step away and I'll close the door here and maybe that will.
Yeah, it's pretty loud.
Okay. Hang on. I
Yeah.
apologize.
It's all right. No problem. This is live, people. We're talking with Bill Shaddle, and he has an amazing ability to be able to talk about very, very difficult scientific concepts, especially when we're talking about the gut bacteria, and be able to bring it down to a language that the average person can understand. So I really appreciate his ability to do that. And yet he lectures to doctors, to health professionals, to clinicians, to allied health professionals all over the world, and has done that for many years. But yet he has the ability to be able to help the average person be able to understand and comprehend these very difficult concepts. So we're really fortunate to have Bill with us tonight. And so I hope that you're really taking in and really being able to absorb what he's saying. This is a lot of wisdom right here.
Thank you. Is that better?
Yeah, that's perfect. So, yeah, I was talking about the Akkermansia bacteria that, as you know, the research shows that it's not so much that you can give people Akkermansia bacteria and make people healthy and make them lose weight, but they found that the Akkermansia is deficient in people who are overweight and obese. So, it ways perfectly what you're talking about. Could you kind of talk a little bit more about that?
Sure. There's a number of different. There's a difference between a correlation and a causation. So where we are right now with the science is they've made a number of observations that we see this type of correlation, which means two different variables seem to be associated together. So obesity and the presence or absence of a certain bacteria. Now, to demonstrate that the one is causing the other is a little bit more difficult, a little bit more, takes more steps, because then you have to control for all the different variables and make sure that you've got a mechanistic understanding of what's actually going on. So one of the things that they think is happening, and whether that's true with the Akkermansia bacteria or is generally true with other types of bacteria still remains to be seen. But one of the things we know that happens is that when there are certain types of bacteria found in the GI tract, there's an inflammatory cascade that gets activated. And the bacteria, they know, contributes to that inflammatory cascade. And the inflammation in the GI tract can contribute to an upregulation of certain chemicals in the GI tract, which causes a change in the dynamics of the absorption, which leads to increased absorption of certain chemicals, which then can change the absorption of different compounds in the GI tract. And when that happens, that inflammatory process gets translated or upregulated in the rest of the body. And we know that inflammation is associated with increased obesity. It's also associated with increased cardiovascular disease. It's associated with type 2 diabetes. It changes the receptors that are associated with how the body uses insulin. And it's a very complex biochemical process, which can then be associated with weight gain, among other things. It can also be associated with arthritis and cardiovascular disease, and even things like neurological dysfunction. And so where you step in and change that dynamic is going to be crucial to how you impact the progression of the disease. And whether or not the right thing is to introduce certain friendly bacteria, or some people have attempted to kill off the unfriendly bacteria with antibiotics. I mean, I'm not an advocate of that, because that's kind of like using a hand grenade to get rid of termites in your house. I mean, you might do that, but you're also going to be causing a lot of damage in other places. So it's a very interesting process and an interesting area. One of the things that is emerging from this is the difficulty in consistently modifying the microbiome or modifying it for a long term. And what I mean by that is they're finding that it may not be the right strategy to try and manipulate the bacteria by either increasing or reducing the amount of the bacteria directly, by either giving or suppressing the bacteria itself with more or less bacteria, but instead increasing or modifying the food supply of the bacteria.
Mhm.
And what I mean by that is, if you bear with me for a second, if you go back through the last 30 or 40 years of looking at people's diets, it's pretty well accepted that as a society, we've gotten fatter for the last 40 years, regardless of the interventions of the government, of dietitians, of weight loss experts. We've gotten fatter as a society.
Diets.
Yeah. And if you factor in, or if you calculate the impact of the changes of all of the macronutrients across the board for those 40 years, look at all the things that have happened. We've switched from complex to simple carbohydrates. We've changed from one type
let's
of
just stop for a minute there, bro. Let's clarify for people what's the difference between a complex and a simple carbohydrate, so people get an understanding
Okay.
that one is good and
Right.
then one has problems if it's done
Right.
not in combination with fiber.
We used to eat what are called complex carbohydrates, and a complex carbohydrate is, for lack of a better term, it's a food that's a long chain of carbohydrates. It's like a starch, and it takes work for the body to break that down. And it's absorbed more slowly versus a type of sugar, and the difference would be eating beans and rice, which are both complex carbohydrates, versus eating a Snickers candy bar.
Mm-hmm.
You can have the same exact amount of calories from beans and rice versus eating a Snickers candy bar. And when I talk about rice, forgive me for a second, but when I talk about rice, I'm not talking about Uncle Ben's converted rice. I'm talking about long rice or whole grain rice or something like that.
With the fiber that's
with the fiber that's intact. Right. It takes a long time for your body to break that down, and that's called
just the way nature provided it. Just the way nature provided, not some big corporation refining and adulterating.
Right. Versus a Snickers candy bar, because calories could be exactly the same, but the amount of time it takes for your body to digest that Snickers candy bar could be minutes versus several hours for the beans and rice. And because of that, because of the length of time it takes for the body to break it down, the carbohydrate in the Snickers gets into your bloodstream very, very quickly and causes a very rapid spike in your insulin, which has all kinds of downstream effects, which are not good things. Versus the beans and rice, which is a complex carbohydrate, which has a much slower uptake and a slower increase in insulin, and a slower release of the energy, and a subsequently much more blunted impact on all of the biochemistry that's associated with it. And that's why we're encouraged to eat complex carbohydrates rather than simple carbohydrates, because it takes longer for the fuel to be metabolized and to burn, and therefore it has less of a negative impact on the body that way. So we switched from complex carbohydrates to simple carbohydrates. So that's one thing that's been damaging. The second thing that's happened is that the type of fats that we've begun consuming have also had a negative effect. We switched from the type of fat that contributes to or we've switched to the type of fat that contributes basically to heart disease. We switched away from the type of fats that our body needs to a type of fat that it wants to store instead of using as a fuel. So anyhow, my point is, we've made all of these changes, which have been
So before you move on, let's talk about what those fats are that we switched from. What are the good fats and what are the bad fats?
Well, the fat, as an example, we've gone from omega-3 oils, which are found in things like cold water fish, to types of fats which are more harmful because they're more difficult for the body to metabolize effectively, basically. And the omega-3 oils are more flexible, they're more fluid. They cause when they're absorbed into your cells, they make your cells more flexible and more, what's the right term?
Permeable.
Permeable. Thank you. They're more
Sure.
permeable, and they're easier for they keep your blood vessels more flexible. That's basically
And then the nutrients could be transferred over into
right.
the cells and get into the different tissues, the brain,
Yeah.
the heart, the liver. If
Right.
it's rigid, it's like more difficult for it to pass through there.
It's
So
more difficult, and it also makes the blood vessels stiffer.
yes.
They are stiffer, and I don't want to get into the biochemistry associated with it, but they are literally more stiffer and more stiff. And the omega-3 oils are much more flexible and more fluid. And we switched from we switched to more of a trans fatty acid, which is not a fatty acid that's found in nature. And we switched away from the fatty acids that are found in nature to one that is less likely to spoil. And so it can sit on the shelf for longer, and it's good for the companies that want to sell it because it doesn't spoil as quickly. But it's not so good for people because, for the same reason, that it's not as healthy for you. So anyhow, the point I was going to make is that when you look at all of those variables, every single one of them has made us less healthy and more likely to get obese. However, and this is the part that I found so fascinating, some scientists went back and added all of those variables together. And even with all of them added together, they don't add up to enough to make us as obese as we are. The one thing that they didn't take into consideration is that we switched away from much of the fiber that we used to eat. If you go back 40 or 50 years ago, or 75 years ago, much of our diet, I shouldn't say it that way, much more of our diet was made up of non-digestible fiber. We ate a much higher percentage of vegetables that were high in fiber that was non-digestible, and a much lower amount of animal fats or foods that were quickly converted into energy. If you add that back into our diet, then that could account for the increase in obesity that we're seeing today. So in other words, it may be not that we as humans are eating the wrong foods, but we're feeding the wrong foods to the bacteria that live in our GI tract.
Mm-hmm.
And that if we would go back to eating more fiber, and I'll touch on that in just a minute, or I'll circle back to that in just a minute, what we would be doing is not just eating a wider variety of foods, but we would be feeding the bacteria the foods that they would prefer, the friendly bacteria that they would prefer. And then the long-term benefit to us is that they would be happy. Those bacteria would be thriving, and the friendly bacteria in particular would then be giving us the benefits that we need, which would then be preventing all these other chronic diseases that we see that are associated with an overgrowth of the unfriendly bacteria.
Okay, so what we need to be doing is eating more foods that are loaded with both good soluble and water soluble fibers, and then be able to eat less of the saturated fat, less of the trans fats, stay away from that, and get more of the omega-3 fats, which is found, as you said, cold water fish, things like walnuts, and pumpkin seeds.
Yeah.
We can get a lot of those foods that have those omega-3 fats.
Yes.
So those are the things we could do. Now let's kind of shift for a minute because
Well, before we move
time's a
on,
factor here. Time's a factor. We got to look at what happens when we get a disruption and we end up having too many of the bad bacteria. What happens when that occurs? And what is the term dysbiosis? That's a
okay,
big mouthful there. What
it
does
is.
that mean?
Dysbiosis. Biosis again is the same root word from bios, microbiome, and pro. Biosis meaning basically means life, but these are the friendly bacteria. So dysbiosis means an upset in the microbiome, and it's when you get an overgrowth of the unfriendly bacteria, and the friendly bacteria have either died off or been suppressed. And understand that there are hundreds and hundreds of different bacteria, different strains of bacteria that live in our GI tract. So the best analogy that I can think of, and I mentioned this before, is a healthy rainforest. In a healthy rainforest, it's not a monoculture. There's not just oak trees. There's dozens and dozens of different kinds of trees and bushes and shrubbery and grasses and plants. There's hundreds of different strains of bacteria, thousands, perhaps thousands of different strains of bacteria that live in our GI tract. And some of them are good for us, many of them are neutral, and some of them are harmful for us. And the thing that keeps the harmful ones in control is the presence of the friendly ones. They just are prevented from overgrowing by the friendly ones. And if the friendly bacteria are not being fed properly, then the unfriendly bacteria overgrow. So think of your lawn. If you've got a healthy lawn of a particular strain of grass, the thing that keeps the weeds out is the presence of the grass that you want to have there. You know, you have a nice garden, and you know to plant certain plants there. The thing that keeps the weeds out, one of the things that keeps the weeds out, is the presence of the flowers that you planted there to prevent the weeds from spreading. And the same thing in the GI tract. So dysbiosis is when the friendly bacteria have lost their ability to prevent the unfriendly bacteria from overgrowing. And one of the things that can contribute to that is too much fat in the diet, the wrong types of carbohydrates, for example, not enough of the friendly fibers that feed the friendly bacteria, use of antibiotics or other types of pharmaceutical agents that can contribute or allow the overgrowth of the unfriendly bacteria. So there's a number of different variables that can do that.
But what most people
Parasites.
don't realize, Bill, is that sure, antibiotics destroy the beneficial bacteria, but pretty much all medications upsets the balance of the good and the bad
They
bacteria
can.
to different degrees, right?
They can. Yeah. Yeah. And sometimes, we recognize that we can be exposed to something that overwhelms our system. And you may be in a situation where you need to save the organism through some heroic method. And
Mhm.
okay, so then you have to repair the damage that's been done as a result of that. So
Good point.
I'm not opposed to an antibiotic if the situation dictates it, but I think we've gotten a situation in our society where people think that an antibiotic is the first go-to
Mhm.
strategy, and I am not a fan of that. Antibiotics have no impact on a virus. So
Yeah.
people who think, well, I've got a cold or I've got a flu, those are viruses, and antibiotics have no impact on a virus. So if they
Mhm.
run to a doctor asking their physician to give them an antibiotic because they've got a cold, they're wasting their time, and
Mhm.
they're potentially causing significant harm to themselves because they're killing off the very good bacteria that could be helping to protect them against viruses in the first place.
So, what are some of the diseases that are associated with these bad bacteria? You mentioned there's a lot of different systems that they affect, but is there evidence to show in the research that there are specific diseases that can be triggered by having too many of the population of the bad bacteria?
Yeah, there are. Bacterial vaginosis is one example. That's where there's overgrowth of unfriendly bacteria in the vaginal tract that leads to things like upper urinary tract infection in women. There's antibiotic-associated diarrhea following of antibiotic use in both men or women following, as I said, use of antibiotics. Type 2 diabetes, cancer, different autoimmune diseases. There's things like different allergies that people can be, or that can be triggered by these exposure to, or the overgrowth of unfriendly bacteria. Things like colorectal cancer, other types of bacterial infection. There's even things, brain function, or ADHD has been associated with overgrowth of unfriendly bacteria. Depression, anxiety, central nervous system dysfunction, that virtually any type of chronic disease that you can think of in one way or another has been associated with unfriendly bacteria, or with dysbiosis in the GI tract. So I I'm reluctant to say that there's no diseases that could not be, that might not be associated with that, but I can't think of any.
Sure. So let's talk a little bit about, is there any, there's such a concern about COVID, and, the people are fearful of that. Is there any connection between the bacteria in the gut and COVID?
That's a good question. There is no evidence that I'm aware of that COVID specifically is caused by or associated with a particular bacterial either overgrowth or die-off. However, there is ample evidence that viral infections in general are associated with different bacteria, either an overgrowth of unfriendly bacteria or a deficiency of friendly bacteria. So we've got good evidence that shows that seasonal cold and flu, for example, are definitely associated with a die-off of the friendly bacteria. And you can actually show, by giving the friendly bacteria seasonally to children as well as adults, that you can reduce the incidence of seasonal cold and flu. So you can give certain bacteria, and there are certain strains that have been identified that you can give them prophylactically and reduce both the severity and frequency of cold and flu, which are viruses. Now, it's a bit of a leap to say that that means that you can prevent COVID. In fact, I would not make that you can't draw that conclusion based on the evidence. But there is good evidence that improving the balance of the friendly bacteria can have a beneficial effect on the overall function of the immunity, of the body's immunity, and can help to support a healthy immune system. So while I can't say, based on the evidence that we have today, that giving these bacteria are going to prevent COVID, I would say that as an overall strategy in helping to stay healthy during cold and flu season, which could help you to stay healthy in the presence of such viral infections as COVID, that it might be a wise tactic, if that makes sense.
Mm-hmm.
So am I putting enough modifiers in there, Dr. Krystosik?
Yeah, that's fine. Yeah. So the connection, you mentioned briefly about the connection between the bacteria in the gut and our brains. Can you talk a little bit more about that? Because I don't think people understand the significance of that.
That's absolutely fascinating. But remember that one of the strongest connections, one of the most significant neural pathways, is between the GI tract and the brain through the vagus nerve. So it really is no surprise that what goes on in the gut would have a significant impact with neurological functioning. And they've identified that dysbiosis is significantly associated with depression, with increased anxiety, with ADHD, with things like Tourette's, with the autism spectrum disorders. And it's unclear at this point whether it's a direct cause and effect or if it's simply a correlation. However, there is pretty compelling evidence that there is an association between dysbiosis and a variety of neurological impacts. In fact, you might have seen just in the past couple of weeks that there was an article in Nature magazine showing a correlation between was it? No, this was an increase in dietary intake of refined foods and an increase in risk to Alzheimer's disease. And they felt that it was due to a change in gut function and gut integrity, and perhaps the bacteria that live in the gut contributing to inflammatory changes in the brain. But it was associated with the bacteria found in the gut. And that was just published in Nature, I think, 2 weeks ago.
Mm-hmm. So the bacteria inside of the gut has an effect on our brains. That's hard for an average person to wrap their head around.
Well, the bacteria.
There's a lot of good research to show that what's going on in the gut is got a tremendous impact, as you're talking about right now. But the average person doesn't comprehend it. I don't think we should skirt over that too quickly, because it's significant, and the research now is beginning to explode with the information about how that is occurring.
Well, these bacteria actually produce neurotransmitters. They produce substances. The friendly bacteria as well as the unfriendly bacteria both produce neurotransmitters, which are then absorbed across the GI barrier and are carried to the brain and have impact on different cells in the brain. And the impact then is what leads to modification of neurological function, either causing depression, causing anxiety, or contributing to the long-term effect that we interpret as autism spectrum changes, things like either on the autism spectrum or central nervous system changes. And don't forget that these changes that we interpret as autism or as anxiety or as depression, these are controlled by compounds, by chemicals in the brain that affect at the synaptic level. They affect the transmission of impulses in the brain. And if these are being produced by bacteria in the gut that are then being absorbed and are affecting us in our brain, it's not a very big leap to understand how the GI tract and what goes on in your gut will have an impact in your brain. In fact, when you stop and think about it for a minute, it's kind of amazing that nobody saw it before, isn't it?
Yeah. I know that for many years I've been on the radio and now on a podcast, but back when I was on the radio 25 years ago, I was talking about the microbiome and the microbiota, talking about the benefits of beneficial bacteria. And I used to have medical doctors call me up and challenge me and say, you don't know what you're talking about. There's no evidence that we have any need for these bacteria. I know. I kind of looked back and had a laugh at that.
I know. I called on, early in my career, I would call on gastroenterologists. And I would talk about bacteria, friendly bacteria. And at the time, the conventional wisdom was that bacteria in your GI tract had no impact whatsoever on physiological function. In fact, a couple of them said, wait a minute, you realize that I have sick people in my waiting room, and you're telling me that you want me to give them live bacteria. Leave my office and don't ever come back. And now, in the past 2 years, a survey has shown that 97% of gastroenterologists recognize the benefits of probiotics.
There's an old saying that's been around for a long time. You probably heard it. I'm going to paraphrase this, but the first generation of scientists that hear something new, they say, "Oh, that's a bunch of baloney. You're off your rocker. You don't know what you're talking about." The second generation that hears it says, "Well, they poke a stick at it and they go, that's kind of interesting. I never thought about that." The third generation says, "We discovered."
Of course it's true. And I said so from the beginning. Yeah, I know.
It's
I
really come
love it.
full circle around
I
the
love it.
fact that what
I love it.
Hippocrates said over 2,000 years ago is really having a really, it's shaking up the medical world and the scientific community. This whole research on gut bacteria back in, I'd say like back in the 90s, there was only maybe 500 papers coming out of research papers per year.
Yeah.
Now we're getting around 10,000
Yeah.
research papers coming out per year
Yeah.
on the gut.
There are entire journals dedicated to probiotics. That's all they publish is probiotics. And now the work on prebiotics, which is the food for bacteria, that's the fiber that bacteria consume, is getting a tremendous amount of attention. And I don't want to get too far away from the prebiotic concept. A friend of mine, who I believe you also know, Deanna Minnick, has talked about a lot about.
We had her on last week on my program, but unfortunately, I was having computer problems, so we're going to have to coming back again. She's so gracious to say she's going to come back.
She's wonderful. Get her to talk about eating a rainbow. She will, because that's a term that I think she coined. But eating a rainbow means eating lots of different colorful fruits and vegetables, because it's the color. It's the compounds in fruits and vegetables that give them their color that is frequently what also gives it its therapeutic value. And the key to feeding the microbiome a good broad spectrum source of food is to eat lots of different varied fruits and vegetables, lots of different color, lots of variety. And that's what's gone out of our diet. We've gotten to where we eat a monochromatic diet, and we have to get back to eating lots and lots of different colors.
Yeah, I'd like to make a point on that, Bill. So when we eat those varied colors, each color is coded for different types of bacteria. There may be like 5 or 10 or 20 different bacteria that love that particular food or particular color. Yeah. So the more diverse our diet is, the more diverse our bacteria is going to be. That's what you're saying.
That's right. That's
exactly. Hey, now, Bill, we're running out of time here, so I want to ask you a really important question, if I may.
Absolutely.
So you've been helping not only the public, but doctors, clinicians, professionals for over 45 years with educating them on this whole concept of, functional medicine, the microbiome, treating the body as a whole, giving it whole foods. What would you like to be remembered for?
Oh, what a great question. I'd like to be remembered for curiosity. I have a basic philosophy of life, and that is that no one has all the answers. And if you maintain a healthy curiosity, which carries with it an undercurrent that maybe I'm wrong, there's always something to be learned around the corner by everyone around you. And if you keep your mind open, you're always open to learning something, and there's always something new out there, and there's always someone who can teach you something new. You're always going to be staying relevant. And I hope that I can always stay relevant. And
okay, so that's beautiful thought. I love that. That's awesome. But I'm going to talk about what you want to be remembered for in the venue of health, the health field.
If I can be remembered for anything, I hope that what it is that if I can take a complex topic and make it simple so that people can understand it and know how to apply it.
Well, I can tell you this much. You did a wonderful job this evening, and I'm certain that our audience loved how you were able to take very complex concepts and bring it down to an understandable bit of information people could take home and be able to use some practical information. Is there anything you'd like to leave us with tonight?
I always learn something from everywhere I go and every person I talk to. So thank you for this opportunity to learn from you.
Okay, well, listen, we're going to have you back hopefully in the future if you'd like to come as a guest.
I'd love to. Thank you.
And so keep in mind that the other side of medicine has an open door to you and the knowledge that you have. And we thank you so much for being with us tonight. So have a blessed Christmas. And we just would love to wish you and your family a happy new year as well.
Thank you, Dr. Jim, and the same to you.
Okay, take care now.
You
Okay,
too.
well, that's it. The time that we have tonight for the other side of medicine. We'll be back next week, so you don't want to miss. Keep abreast on what's going on. Go to theothersideofmedicine.com and we'll keep you informed. And I'd like to wish you Merry Christmas as well. And we'll talk to you next week. Ciao for now.